Okay, let me now introduce how we evaluate named entity recognition. In the named entity recognition task, we have a sequence of word tokens, and what we're going to want to do is predict entities. So we're going to want to predict that this is an organization, these two words. These two words are a person, this one word is an organization. So in general, we can have entity names that are several tokens long, and we want to identify both the boundaries of the entity and then also its class, that this is a person. Now, you can think of that as making a classification for each token in sequence, but in a way that doesn't terribly make sense, because really our unit of interest is these whole entities, the person and the organizations. And so the standard and better task-motivated evaluation that's used for named entity recognition is to evaluate per entity, not per token. And so when we're working out our 2x2 contingency table of true positives and so on, and here's our system guess, what we're going to do is do it at the level of entities. So in this data, there are 3 entities, and we could imagine perhaps that our system identified this one as a person name and identified this one as an organization name, but missed this one. So what we'll be doing is saying that there are 2 true positives and 1 false negative out of the 3 tokens. And so the precision of our system here is 100%. Everything it says is right, and its recall is 2/3. Okay, so that looks okay. But when we get into the details, it gets a little bit trickier than that. So the problem is that recall and precision are straightforward for tasks like web search, information retrieval, or text categorization, where there's only one grain size that you're putting a classification on a document. But in this case, what we're doing is putting classifications on subsequences of words. And the precision, recall, and F measures actually behave a bit funnily when that happens. So here's an example to give you a good sense of the problems which actually occur commonly in systems. So here's the piece of text: First Bank of Chicago announced earnings. And the correct entity is right here, First Bank of Chicago, which is a single organization name. However, our system made a little bit of a boo-boo. Our system has said Bank of Chicago is the name of an organization. And so that means it's made a boundary error. It's got the right boundary of the entity correct, but it's got the left boundary of the entity wrong. And this is the kind of error that NER systems make a lot. And it's very easy to see in this case why it's made the error, because first is also a common noun, and at the start of a sentence it's perfectly reasonable to have the common noun of first Apple announced this, and then Microsoft announced this. So intuitively you might feel like, really, in this case the named entity recognizer should be counted as mostly correct. It identified that there was an organization name here, and it labeled 3 of the 4 tokens. But that's not how things work using the set-based measures of false positives, false negatives, true positives and true negatives when you're working on sequences. Because what we say is that the true annotation is that there's an organization that spans from token 1 through token 4 of the text. Whereas what our system guessed is that there was an organization that spanned from token 2 through token 4 of the text. And each of these claims is taken as a unit and is put into a set of claims, and then we count the number of matching claims, that's the true positives, and then we count the set differences in both directions, and that gives us the false positives and the false negatives. So what we end up with in our classification in this case is that this is a false negative, and that this one here is a false positive. And so actually our system will be scored as having made 2 errors if it does this. And so actually the system would have scored better in an F1 evaluation of named entity recognition by having labelled nothing. Now that can easily seem kind of wrong to you, and it has seemed wrong to other people, so there have been various suggestions to provide measures for evaluating named entity recognition systems where you get partial credit for doing things like this, for getting an entity almost right. So for example, the Muck score that was used in some of the prominent early evaluations of named entity recognition, it had an algorithm that gave partial credit for cases like this. But once you do that, then there are these complicated questions of how much partial credit to give in which cases, and it's not exactly clear, and you have various arbitrary parameters. So really, most of the rest of the field hasn't gone there and has ended up using this straightforward F1 measure for named entity recognition, despite the complexities with boundary errors that I've just tried to illustrate. Okay, so that should give you a good sense of what these measures of precision, recall, and F-measure are, why they're useful, how we use them for named entity recognition, but also a slight sense of how you have to be a little bit careful interpreting the numbers in that case.